the Institute of Technology, College of Engineering, Yeldrao, in Mechanical Engineering Department as Assistant Professor. In this video, we will discuss about the introductory part of the IC engine. Let us start with the definition of the heat engine. The main function of the heat engine is to convert heat or thermal energy along with chemical energy to mechanical energy, which can be used to do a mechanical work. There are two types of the heat engine. The first is internal combustion engine. The second one is external combustion engine. The definition of the internal combustion engine is, in case of the internal combustion engine, the combustion of the fuel takes place inside the cylinder. Hence it is called as an internal combustion engine. The best example is the car engine. The second is the external combustion engine, the engine in which the combustion of the fuel takes place outside the cylinder. Hence it is called as the external combustion engine. The best example is gas turbine. As far as the application of the heat engine is to be concerned, again they are categorized into internal as well as external. Few of them are listed here. The heat engine are used in car engines like all automobiles, transportation vehicles. It is used in gas turbine, ship application, marine applications, railway engines, aeronautical applications, some stationary application like generators, also some agricultural equipments. The IC engine are mostly used. The second important point of the IC engine is the terminology. The terminology include n number of the parts of the IC engine. The first important part of the IC engine is cylinder block. It is the heart of the engine. It consists of three parts. The first is cylinder, the second one is port, and third one is passage through which the cooling water is continuously circulates. The material used is generally aluminum alloy. The second important component is piston. It is the main active part of the engine. The main function of the piston is to compress the fresh charge during the compression stroke. The material used to manufacture the piston is aluminum alloy. The third component is combustion chamber. The space enclosed in the upper part of the cylinder is supposed to be combustion chamber. The material used is cast iron. Next important component is inlet and exhaust valve. The function of the inlet valve is it allows the fresh charge into cylinder. Also, the main function of the exhaust valve is to provide the passage for the burnt gases to escape out from the cylinder to the atmosphere. The next important component is connecting rod. It connects piston and crank. The function of the connecting rod is to transmit the power produced in the cylinder to the crankshaft. The material used is medium carbon steel, or sometimes alloy steels are used. The next important component is crankshaft. The crank is a lever that connected to the end of the connecting rod by the pin joint with its other end connected rigid to the shaft. It's called as a connecting shaft. The main function is it converts reciprocating motion into rotary motion. The material used is generally aluminum alloy or sometimes cast steel. The manufacturing technique is forged. The next important component is the flywheel. It is one kind of the energy storage device. The material used is cast iron. So this is the terminology of the IC engine. It consists of n number of the parts like cylinder block, cylinder head, piston, combustion chamber, inlet valve, exhaust valve, then connecting rod, crank, piston pin, cylinder, etc. The next important point is classification of the engine. The heat engine is divided into two types. The first is IC engine, is called as the internal combustion engine. Second one is external combustion engine. Again, the IC engine is divided into two types, rotary, reciprocating. Again, the rotary is subcategorized into Wankel engine and open cycle gas turbine. Reciprocating is also categorized into two types, petrol as well as diesel engine. The external combustion engine is again divided into two main types, the reciprocating, rotary. Reciprocating is again divided into two types, steam engine, Stirling engine, rotary, is again categorized into two types, steam engine and closed cycle gas turbine. The next point is difference between SI engine and CI engine. SI engine is nothing but spark ignition engine, simply petrol engine. The second one is CI engine is nothing but compression ignition engine, nothing but simple a diesel engine. The SI engine works on Otto cycle and the CI engine works on diesel cycle. As far as the speed is to be concerned, the speed range is in between 3000 to 6000 rpm in case of the SI engine, and in case of the compression ignition engine the speed range is in between 400 to 3500 rpm. The starting is easy in case of SI engine, it requires very less cranking effort, but in case of the CI engine it requires a large cranking effort, so starting is little bit difficult in this case. The initial cost and maintenance cost is less in case of the SI, where in case of the CI engine the cost of the maintenance as well as initial cost is more. It produces less noise, it produces more noise. Weight per unit power is less, the weight per unit power is more. The specific fuel consumption is more in case of the SI engine, but in case of the compression ignition engine the specific fuel consumption is less. Hence the fuel used is a petrol. It is costlier than the diesel, it is volatile and fire hazard is more. The fuel used in the CI engine is diesel, it is cheaper than petrol, it is less volatile and fire hazard is also less. So this is the comparison in between SI engine and CI engine. As far as SI engine is to be concerned, the compression ratio it is in the range of 7 to 11, and in case of the CI engine the compression ratio is more, it is in between 11 to 22. This is the most important part of the IC engine, the construction and working of 4-stroke petrol engine. There are basically 4 stroke. The first is suction stroke, second one is compression stroke, third one is expansion stroke, it is supposed to be power stroke, and fourth one is a exhaust stroke. In case of the 4-stroke petrol engine we will get 1 power stroke by 2 revolution of the crankshaft, means up to 70 to 720 degree revolution is there, means crank rotate twice and we will get a 1 power stroke. So when we talk about the suction stroke, when the crank rotates continuously in that particular direction, the piston moves from TDC, that is top dead center, to BDC, that is bottom dead center. When the piston is start moving from the TDC to BDC, the mixture of the petrol and the air is come inside from the carburetor and it locate on the top side of the piston. When the piston is reached at the bottom position, that is BDC, the suction stroke is completed. At the time of suction stroke, inlet valve is only open and exhaust valve is closed. When the crank rotates again continuously, the piston start moving from BDC to TDC. At that time, whatever the mixture of the air and petrol is to be situated or stored on the top side of the piston, it gets compressed at a high pressure. When the piston is reached the nearer position of the TDC, the spark get ignited, ignition takes place and combustion of the fuel takes place. At that time, the both valve, that is inlet valve and exhaust valve, both are closed, and the tremendous amount of the heat energy are produced at the time of combustion process, and ultimately we will get power stroke. Here the piston is start moving suddenly from the TDC to BDC. Here the power stroke is completed. Here we get power stroke, that is called as expansion stroke. In this particular case, both valve, suction valve as well as exhaust valve, both are closed. When the crank is continuously rotating, at that time the piston start moving from BDC to TDC. At that time, whatever the burnt gases are there, it can be escape out from the exhaust valve. In this particular stroke, the inlet valve, that is suction valve, is closed, but exhaust valve is still remain. Hence, In case of the 4-stroke petrol engine, we will get 1 power stroke by 2 revolution of the crankshaft. The next point is construction and working of the 4-stroke diesel engine. Again, the strokes are same. The first is suction stroke, second one is compression stroke, third one is power stroke, and fourth one is exhaust stroke. The basic difference between SI and CI engine is at the entry time only the air is enters in case of the diesel engine, but in case of the petrol engine the mixture of air and petrol come inside. Now in case of the suction stroke, when the crank rotates, the piston start moving from TDC to BDC. At that time the fresh air from the atmosphere are come inside and it locate on the top side of the piston. In this particular case, the inlet valve is open and exhaust valve is closed. The valves are operate on the pressure difference. When the piston reached at the BDC position, at that time the suction stroke is complete. When in case of the compression stroke, the piston start moving from BDC to TDC. At that time, whatever the air is stored on the top side of the piston, it get compressed at a high pressure. As discussed earlier, the compression ratio of the diesel engine is more as compared with the petrol. In petrol, the compression ratio is in between 7 to 11, and in case of the diesel engine, it is in between 11 to 22. So because of the high compression ratio, the fuel get injected in that particular area, and because of the high compression ratio, the ignition takes place and combustion of the fuel takes place. After combustion, the tremendous amount of the heat is produced, and that particular heat and tremendous amount of the heat pressure is responsible, or it forced on the top side of the piston, and piston start moving down suddenly. Hence here we get the power stroke. In case of the power stroke, both inlet valve as well as exhaust valve are closed. The basic difference between SI and CI is, in case of the SI engine, for ignition purpose, spark plug is there. The main function of the spark plug is to produce the ignition action and then combustion will start. But in case of the CI engine, the compression ratio is more. When the fuel is injected in the high compression region, then it get automatically ignite and combustion of the fuel takes place, and we will get the power stroke. In case of the power stroke, the piston is moving from TDC to BDC. In case of the exhaust stroke, the inlet valve is definitely closed and exhaust valve is open. So whatever the burnt gases are produced, it get escaped through that particular cylinder to the atmosphere,